Secondary wires, spark plug wires, and the coil wire are a common source of trouble in an ignition system. Always inspect them closely. Make sure none of the wires have fallen off or are loose. Check that any plastic separator clips are installed properly. They help separate wires and keep them away from metal engine parts. Reinstall any clips that are loose or have fallen off. Wire leakage occurs when high voltage passes through the insulation to ground. To test spark plug wires for leakage, spray water on the wires. If the engine starts to miss, replace the wires. A spark intensity test, also called a spark test, measures the brightness and length of the electric arc at the secondary wires. It provides an easy way of checking the general condition of the ignition system. An ohm meter is commonly used to check the internal conductor of secondary wires. Place the ohm meter across each end of the secondary wire and measure its resistance. Typically, secondary wire resistance should not be over approximately 5,000 ohms per inch. An oscilloscope is often used to check the condition of secondary wires. The secondary waveform, or a kV bar graph, will show the amount of voltage used to fire each spark plug. An open plug wire will show excessive voltage and a tall line on the scope. A leaking or shorted wire will show a low voltage or a short waveform. In general, you should compare the minimum and maximum kilovolts needed to fire the spark plugs. If any voltage is extremely high or low, it indicates a problem with a plug wire, spark plug, or other secondary component. When removing a spark plug wire, never pull on the wire. Grasp and twist the boot to free it from the spark plug. If you pull on the wire itself, the conductor can break, ruining the wire. The distributor cap or the coil module will have wire numbers that correspond to the engine cylinder numbers. This simplifies wire replacement. The wires themselves may also be numbered. This helps keep wire lengths organized during plug wire installation. When replacing spark plug wires, it is easiest to replace them one at a time. This will help prevent crossing wires to the wrong cylinders. Make sure wires are installed in any organizing clips as recommended by the manufacturer. This will prevent wire damage and leakage. If all the wires are removed at once, you should refer to the engine firing order and a service manual diagram like this one to install the wires correctly. The service manual will give a top view of the distributor or the coil assembly with numbers that correspond to each cylinder number. Simply connect the same tower and engine cylinder numbers to route wires correctly. When installing the wires, you should hear a clicking sound when the wire is properly seated. Some common spark plug problems include the following. Flashover occurs when the electric arc passes down the insulator under the boot. This is caused by dirt or oil on the boot. Wire and plug replacement would be needed. A cracked insulator is due to physical damage and can short the high voltage to ground. A fouled plug has deposits on its tip, so voltage is shorted up the insulator tip to the metal body of the plug. The firing line will be too short if the current is shorted before the plug gap. 4 to 18 kV is normal depending on ignition system design. If the firing line is too tall, a wide spark plug gap may be the cause, or you may have an open somewhere in the secondary. Another indication is spark duration, which should be about 1 to 2 milliseconds. If shorter or longer in duration, you found a problem. To replace spark plugs, use a spark plug socket, ratchet, and extension. Sometimes a swivel is needed to gain access to the spark plugs when the engine is installed in the vehicle. Break the plugs loose, then spin them out. As each spark plug is removed, read the spark plug. This involves inspecting the insulator and tip for abnormal conditions. Here is a carbon-fouled plug caused by slow-speed driving, a plug heat range that's too cold, a weak ignition, or an over-rich fuel mixture. Always correct the source of these troubles before installing new spark plugs. This ash fouling was caused by poor fuel quality or a slight amount of oil entering the cylinder. This spark plug insulator was shattered by a pre-ignition or detonation. To gap the spark plug, use a wire feeler gauge. Slide the correct size gauge between the side and center electrodes. If the gap is too wide or too narrow, bend the side electrode until the gauge fits properly. A small tool is usually provided on the feeler gauge for bending the side electrodes. After bending the electrodes, recheck the gaps. The gauge should drag slightly when pulled between the side and center electrodes. A slight drag shows that the correct gap has been obtained. When installing the spark plugs, hand start the plugs. Don't use your wrench. This will help prevent cross-threading the spark plugs into the heads, causing serious damage. Align the spark plug and rotate it by hand. After the plug is started, you can use your ratchet to spin the plug down into the head. After bottoming the plug, give the wrench another 1/4 turn and the plug will be seated fully. Do not over-tighten the plugs, or they can be almost impossible to remove. Make sure you install the spark plug wires fully. Begin distributor service by inspecting it for obvious signs of trouble or damage. To remove the distributor cap, you may have to pry off spring clips like these. Use a screwdriver to pry the clips outward so you can lift the distributor cap off the distributor body. Some caps are held by screws. Some screws have to be unscrewed fully. Others are pressed down and turned 1/2 revolution to free the cap from the distributor. Lift off the cap without damaging the rotor. With the cap removed, inspect the inside of the cap for problems. Look for cracks in the cap or carbon traces. Excess burning around the center terminal is also common. Severe burning can keep the engine from running. This burnt cap tower caused a dead miss in the engine. Inspect the rotor for the same kinds of troubles. Look for burning and carbon traces that could affect performance. Replace the distributor cap and rotor if you find any signs of problems. Some rotors slide off their shaft. Others are secured with small screws. You will need to remove the screw to replace the rotor. A rotor will only install facing in one direction. A tab and a notch must be aligned to install the rotor correctly. If you do not align them, or if the rotor is not fully seated, severe cap and rotor damage can occur upon engine starting. A pickup coil is another common source of trouble in a distributor. The windings in the coil itself can break, or the wires leading to the pickup coil can break internally. Also, check for play in the distributor shaft. Excess play could affect trigger wheel action. An ohm meter is often used to test the pickup coil. Connect the test leads across the pickup coil wires and to an ohm meter. Compare your ohm meter readings to specs since values vary. If the ohm meter is below or above spec limits, replace the pickup coil. A crankshaft sensor is comparable to a pickup coil in a distributor. A few types are adjustable. On older systems, some distributor pickup coils can be replaced simply by removing their screws. Others are riveted to their mounting plate. To replace pickup coils that surround the distributor shaft, you must remove the distributor drive gear and distributor shaft. By sliding the shaft out, you can replace the pickup coil. It is important to remember that if repairs are needed on newer distributors, a new or remanufactured unit is normally required. To install a distributor, line up the rotor and housing as removed. If not marked, rotate the crank until you can feel air blowing out of the number 1 spark plug hole. Then align the timing marks on top dead center. Slide the distributor down so that the rotor is pointing at the number 1 spark plug wire. Make sure the distributor housing is fully inserted. The oil pump drive rod can sometimes not engage into the distributor shaft. Lightly snug the distributor hold-down bolt before adjusting ignition timing. With the advent of distributor-less ignition systems, ignition coil service has become more challenging. First, inspect the coil for physical damage, burning, carbon traces, and other troubles. Your oscilloscope should display about 5 coil oscillations at lower engine speeds. The coil oscillations can be seen right after the spark line, which shows the spark plug firing. You should also check spark duration. Insufficient spark duration might indicate a coil problem. Spark height also indicates coil output. If too low on all cylinders, coil voltage may be insufficient. By connecting a spark tester to one of the wires, you can measure approximate maximum coil output. An ohm meter can also be used to test an ignition coil. Follow service manual procedures to connect the ohm meter across the primary and secondary windings of the ignition coil. With multiple coils, this can be fairly complex. Your shop manual diagram, like this one, will simplify testing. To replace an ignition coil, you must normally unbolt it from the engine. Then reinstall the new coil assembly in reverse order of removal. Make sure you tighten the coil mounting bolts or bracket properly. Some ignition coils are mounted inside the distributor cap. By removing the plastic cover, you can gain access to the ignition coil. It is held in place with small screws. Most vehicles built from the late 70s to the mid-90s have an electronic ignition system that uses a distributor. The brain of this type of system is the Electronic Control Unit, or ECU. This module controls when the ignition coil switches on and off. The ECU performs the same basic function as a set of points, but is much more reliable. ECUs do sometimes fail. A bad ECU will produce a wide range of problems. The engine stalls when hot. It cranks but fails to start, or the engine misses at high or low speeds. A technician can identify if an ECU has failed by performing a simple test called a troubleshooting chart. Manufacturers' troubleshooting charts provide a path of instructions for the mechanic to follow in order to pinpoint the exact problem. After removing the distributor cap and rotor, connect a digital volt ohm meter, or DVOM, and while following the flowchart, back probe the wiring for the ECU. If your tests find a bad ECU, replace it. Remove the wires from the unit and its fasteners. Then lift out the old ECU from the distributor. Before installing a new unit, apply special grease to the bottom of the ECU. This compound helps heat transfer out of the ECU circuitry to prevent abnormal operation or even circuit damage caused by overheating. Fit the new ECU into place, then install its fasteners. Snug them down without over-tightening. Starting in the late 90s, manufacturers began equipping engines with direct ignition systems, or coil-on-plug systems. In this type of system, the engine has an individual coil mounted directly on each spark plug. A Powertrain Control Module, or PCM, directly powers each coil. The PCM controls exactly when each coil is fired, depending on the needs of the engine. This system is extremely efficient because it reduces the total number of ignition system parts down to 3 major components: a coil, spark plugs, and the powertrain control module. The tools needed to diagnose the PCM and related systems are a service manual, database, a scanner, and a DVOM. To start your diagnosis, check the vehicle for codes using a scan tool. Write the retrieved codes on the service repair order. Next, look up the codes in the service repair manual database. Once you locate the code in the manual, follow the flowchart designed for that code. Normally, you would start by checking the resistance reading on a particular coil, followed by checking the wiring to and from the PCM. The most common failure with this type of ignition system is a shorted ignition coil or worn spark plugs. Replace the parts needed according to your flowchart and tests. Older engines should have their ignition timing checked and adjusted if not within spec. Ignition timing is very critical to engine power and economy. A timing light is used to adjust ignition timing. It is connected to the number 1 spark plug wire and to a source of battery power. Then the timing light is aimed at the timing marks. The timing marks are usually on the front crank dampener, but they may also be located on the flywheel. With computerized or electronic control of the ignition timing, you must often trigger the system into base timing to check ignition timing. This can be done by unplugging a spout wire near the engine, like this one. With the engine idling and any vacuum advance lines disconnected, you can check timing. If you have to adjust ignition timing, loosen the distributor hold-down bolt. Then, by turning the distributor housing, you will change ignition timing. The line on the dampener must align with a prescribed mark or degree marking on the pointer. To advance ignition timing, rotate the distributor housing against the direction of rotor rotation. To retard ignition timing, turn the distributor housing with the direction of the rotor rotation. When your timing is adjusted properly, tighten down the distributor hold-down. Then, recheck your setting.